Alright, this is a microgrow greenhouse automation system. Most of them have a couple common components. This greenhouse has a pretty basic setup. You have a contactor and relay panel, which is not serviceable to the customer, but this is where the actual components are that turn on any of the motors, any of the solenoids. Anything electrical in the greenhouse will be wired through this component. This is what we consider the ProCom control unit. This is the heart of a microgrow control system. There can be more than one, there can be expansion modules, but you're always going to have at least one ProCom. This is where you set your programs, can control everything in the greenhouse, and it's really the prime functioning component. This is a WeatherMaster control station. This will also have a physical weather station that will get mounted either on the roof. In our structure, it's mounted on our building roof. This will take your outside weather, it'll tell you your outside data, your sunlight, your wind and wind speed, and allow you to set alarms and other parameters off of that. This is a misting and irrigation controller. This is for if you have automatic watering systems, if you have a tropical climate and you want to mist your greenhouse every, on an hourly schedule, that's what this unit is for. So what we'll do is we'll start with the ProCom control unit, how it operates, what it allows you to do. Basically, you have all your components will be labeled on your control unit. Every switch will have 3 positions. You have your left, which is your on, your center position, which they're currently all set at as off, and your auto. On and off will force a component to do something whether or not the program tells it to. Like if I take the circulation fans right now and turn them on, the circulation fans in the greenhouse will turn on whether they're supposed to or not. Just like if I force them off, they're automatically going to turn off. And you can do that with anything that the ProCom has. Now what it will have though is if you have something that has an open and closed state, particularly vent motors and shade motors, there will be 2 switches, one's for open, one's for closed. If you push both of them on, it will only do one of the 2 things. It obviously can't open and close at the same time. You can't damage it by flipping both, but obviously it's not going to listen to what you're telling it to do if you try to tell it to open and close at the same time. There's a safety interlock switch that only allows one switch to actually operate, even if both switches are flipped. So what you have when you're setting up a ProCom unit, you have 3 switches on the top left. You have the left, which is run and set, your middle, which is prior and next, and your right, which is actually changing values. Essentially, when you're programming a microgrow, you want to work left to right. So say you start with your left and you want to set. You'll notice that the light goes down to the next item. Set program is the most important programming option for a greenhouse operator. This is where you get to set your parameters on when you want something to happen. So basically where we started in set program is cooling 1 and it's set at daytime. So right now it's set to automatically start cooling in the greenhouse at 71 degrees. You can change that value with the value toggle switch. If you want ready to move on to the next parameter, you hit next, which is your center button. That allows you to switch, in this case, to cooling 1 nighttime, which allows you to have different parameters for day and night. You can also enable a midday and evening mode, which we'll get into later, and then you would have 4 set points in here. However, it's normally most common to have a day mode and a night mode. Then you'll move into your heating parameters with your center button, changing your value wherever you feel fit. Your vent temperature is when you want your actual vents to open. There's going to be labeled as vent 1, vent 2 if you have more than one vent, whereas we have a ridge vent and an eve vent in this greenhouse. The ridge vent is vent 1, your eve vent is vent 2. It's always top to bottom also. So then we would move into our vent 2 set points. Shading set points. This greenhouse does not have shades, but if you have shades in your greenhouse and you have a weather station, you can set the shades to function based on outside sunlight. Outside sunlight, full sun is roughly considered 1,000 watts per meter squared in most of the country. It can vary. So 500 watts per meter squared is a common set point for shading. Obviously you can change that as needed. Fogging is humidity control. This can be done in various actual ways to operate. You can use fogging fans like the one above our head here. Basically when a fogging fan turns on, it provides water to a fan, increasing the humidity through mist. You can also do low pressure fogging nozzles through hose and 24-volt solenoids, and there's a wide array of humidity control systems. So then you can this is your humidity set point in relative humidity. So this fogger in the daytime will keep the humidity above 50% relative humidity, and at nighttime above 40. You can also set a fogger to be connected to the temperature. This will allow you to use, per se, an exhaust fan in conjunction with the fogger to effectively create some evaporative cooling. This is more commonly used in greenhouses that do not have an actual cooling system. This greenhouse has a 2-speed evaporative cooler, so we do not use the fogger for temperature, because if you use a fogger as a way to cool the greenhouse, you're also going to increase the humidity inside the structure. Dehumidification 1. This feature can be linked to any component in the greenhouse. They can also be linked to dehumidification systems. However, they're normally linked to exhaust fans, intake shutters, and circulation fans. And then that's your set point. Next, you can run reports on historical data. This will go through the high and the low for your days. If you have a computer, it's more effective to use the microgrow linking software. It allows you to remotely program and graph to Excel spreadsheets. But the run reports is available. It does not export to anything. It's for locally viewing data on the unit itself. Calibrate is for you have a temperature and humidity sensor in every zone of your greenhouse, and you also have your weather station data. The sensors in a microgrow control system are what we call resistive. Basically, the calibration is directly related to the length of wire. So these can adjust over time with varying resistances and wires. This allows you, if you want to bring a temperature probe into your greenhouse, verify the temperature against what you see here, and you can calibrate it to match the actual air temperature. Same thing with humidity, and then your outside weather station data is available too. And your shading calibrations are for your covered and uncovered state. Normally they stay at the default. There's very few occasions where you would want to alter that. Set system is very important also. This is where you set your time of day and your day. Where this comes into play is setting your sunrise and sunset times. So you want to make sure that your time and day are correct. And your sunrise and sunset, you can change, if you want to follow, you can change it every month. Or more commonly is just to change it with the seasons, either quarterly or biannually with your winter and summer time differences. And that will set the mode and function for features later in the structure. Your light sensitivity is how fast your weather station will react to changes in light. Medium is the default. If you feel that it doesn't react fast enough when a cloud comes in, you can increase it to high sensitivity by the value button. Day mode you can set to a specific time. More so we link it directly to sunrise. And the same thing with, we have the midday and evening in this greenhouse disabled. Basically, we do not recognize the difference between morning, lunchtime, evening, and night. We see only a daytime and a nighttime parameter. If you have perhaps a tropical plant that you like to have a morning high humidity, where you're in a tropical, you got a plant from a tropical island that it rains every morning, you could use the morning as a rainy time and then use midday from say 9 to noon, and you can use that function for a variety of purposes. Review input and output assignments is not open to the end user. This is where you can alter programming data for the actual function of them. If you need to edit something, some form of equipment, you can call us at Solar and we can either walk you through it or provide a service call to fix that problem. Remote ID code will also be set by default. This is for if you're using a computer link software set, you can give each unit its own specific ID code so you know which system is which and you can rename them accordingly. Linking air is where you can link your air circulation. Air circulation is one of the more difficult things to do in a greenhouse as they can be linked to a lot of features. This particular greenhouse has air to output 1, which is our ridge vent. Air 1 is on if the vent is not closed. Basically, if for whatever reason the greenhouse vent wants to be open, our circulation fans will also be open, will be running. You can link them to sensors, say outside temperature. You can say if the inside temperature is this, you can also turn on by changing your values. You can link to one sensor, as many sensors as you want to link it to. And that's it for set system. Now we move into actually programming individual components. So hitting the set button will move you into the set cooling. You can always know where you're at by where the LED is lit on the left side of the unit. If you have multiple cooling stages, it'll say cooling 1, and if you have 2 stages, you'll be able to scroll through everything and then it'll run through the same options in cooling 2. What you have here is the ability to adjust your differential. Where, say for example, this greenhouse has a cooling set point of 72 degrees. The cooling will engage at 72 degrees and will run until the temperature drops 2 degrees. That's our differential here. That is what sets the time frame on how long it runs. So this cooling phase will turn on at 72, will run until the greenhouse hits 70 degrees and then disengage. Your timing is the offset of the unit. These are set by default and related to the equipment being hooked up to them and should not be changed. This is where you can also link something to the dehumidification set point that we said. If we would want to link cooling 1 to the dehumidification, we would increase the value so it says now the stage 1 will function on dehumidification. However, we do not use that feature in this greenhouse, so the dash means disabled. Same thing for the delay. You can adjust a function for changes in solar parameters outside. This may be used for lighting control, but it's not a very common functional feature. It is there though. Your set point ramp is the ability to delay the time in which your environment will change. This is important with some plants that are sensitive to rapid temperature change. You can say, I only want it to go 1 degree per every minute, or you can put it at 1 and let it ramp up at 1 degree a minute, or you can set it at 0, which disables it and lets it ramp at whatever speed it would like to by the power of the unit. Linking to an output allows you to link a feature to something else. Like if we wanted to link cooling 1 to ridge vent, we can go like this. We can link to output 1, and now we can say cooling 1 will do something, which you can change. You can set it to max if the vent is not closed. Now, however, that's not a feature that we're using for our cooling system, but it is available. One of the functions for that is if you have an outside air cooling system, like a large evaporative cooler, and you need somewhere to dissipate the pressure to, you would link your ventilation to your cooling system so that your ridge vent would open when your evaporative cooler turns on to allow you to push the hot air through the ridge. And that's how you set your cooling data. Your heating, after hitting left, is very similar to your cooling set points. You have your differential, your timing, being able to link to dehumidification, solar adjust, ramp, and your length. So your heating and your cooling are identical settings, obviously just on the opposite end of the temperature spectrum. Set ventilation is for your vents, if you have operational ridge or eave vents. You can set how many positions they open. You can either do 0 to 100%, which is how this greenhouse operates with 2 positions. You can set it to 3 positions, which will stop the vent at whatever percentage you say in the upswing. You can set it 25% and then open to 75% and then 100. And that's, you select how many and then you select your positions. And that says how far each position will function. And then the max position is 100% open. You set your vent opening time. This is not 100% critical. What this does is when the vents are powered, they open to a certain set point. The opening time is what allows you to set a time frame for the opening. So say you time the vent takes 15 seconds to completely open and close, and you say to open 50% is what you tell it to do. It will know that it normally takes the vent 15 seconds, and it'll stop and depower the unit at 7.5 seconds so that it knows that's your 50% rough opening. Your safety delay for vents, or if you're using a vent motor that is not a Solar Innovations vent motor, that needs to have a safety delay. Some of the centrifugal motors and some of the other brands require that. A Solar Innovations linear actuator does not require a safety delay. They're internally safety monitored. So you can leave this at none for one of our linear actuators. We have our vent 1 linked to cooling stage 1. What that means is that if our cooling system turns on in here, our ridge vent will open. That's for, like I discussed earlier, it allows us to push that extra pressure in the room through the ridge vent. If you have an outside air source like an evaporative cooler and you do not link your ridge vents to it, you will pressurize the room, making the doors difficult to open, and some other problems that can come with that kind of item. And we have it linked to position 1 on cooling stage 1. Linking to overrides is available on ventilation. What that is, if you notice, it's linked to override 1, 2, 3, and 4. When we get to the Weathermaster's box, I will explain what those are used for. And that's what we want it to do. We want the vent to close on each override. Linking the dehumidification is available, and the differential. Differential for a vent. Say the vent's set to open at 76 degrees, the vent will stay open unless it goes 1 degree below the set point of 76. So at 75 degrees, the vent would reclose for this greenhouse. Solar adjust is also available, and a temperature ramp. For a vent is not as practical, mostly because the ramp is so designated on the outside and inside temperature that you can't control it as well as you can with mechanical means. Then it will go through all the same settings for every vent. So now we moved into vent 2, which would be RE vent. So when you're done with your vent, you can go to shading if it's available in your system. You can link the shades. Mostly your differential will be to your outside weather position. We highly recommend, and the most functional way to run a shade system in a greenhouse is 2 outside light transmittance. And that's how we install them in almost all of our greenhouses. Whereas this one has a differential of 40 watts per meter squared. So we had our shade set at 500 watts per meter squared to close. The outside sun would have to reduce to 460 watts per meter squared to allow the shades to roll up. You can set that differential to anything you want. That's basically so that you're not cycling your shades every couple seconds, every time a cloud changes over the sunlight. It gives you the ability to control that. Same thing for the closing time. That way if you tell it to adjust to 50%, it knows roughly how long it takes to make that adjustment. Heat retention is the ability for the shades to know, in this case, to go to 100% closed if the mode is night. What that allows it to do is many shades that we sell are what we call Revolux fabric, which have a metallic coating on the inside that reflect heat back within the structure. So at nighttime, when you're not gaining heat from the outside and the sunlight, you can set that to 100%. At nighttime, the shades will roll down, giving some insulation and some reflective properties to the heat within the greenhouse to help retain some of the heat so you're not reheating as much during the nighttime when you have no other heat source, or to supplement your existing heat source. And you can cancel heat retention mode when it turns to day. That's what disables heat retention when you come back to your daytime. And then you can heat retention 2. You can set them on different set points if you want to have heat retention exist for nighttime and certain outside temperatures. Say you want to shut the shades, even if the sun's out, to keep heat in if it's below freezing outside. You can set that using a second set point. And that's your shading. Fogging is your humidity. This one here is the same thing. You have the adjustment for the differential in temperature if you're using the fogger as temperature. Setting set points in here, if they are disabled, they will be there in memory, but they will not engage because we had set the temperature to disable in the set program. Now the fogger will turn on for a 2% relative humidity differential. So I want to say it was 50% relative humidity during the day. It will run until it hits 52 before it shuts off. And your differentials are more for how tight of tolerances do you want. Obviously your motors will be running more frequently with 2% differentials than 5 because they're going to be only running at 2%, letting it drop and running again. However, that keeps a much tighter environment. Obviously your plants will have their own ranges that they're allowed to function in, and you will set that based on that value. Your fogging timing, same thing for your motor. Maintained is what allows you to either maintain or pulse the signal to the water solenoid. Maintained is the most effective in humidity control. However, on occasion, if you have a fogger located directly over a doorway and you're a little worried about how wet the ground's getting, you can set it to pulse, which will pulse the water flow and give it a little more time to evaporate before it starts laying. And that's your fogging set points. Dehumidify, we have disabled, but this is where you can enable the dehumidification setting and link it to whatever items you want to link it to. So if we enable it, we have the runtime. So this is where if you use the dehumidify settings at the top point, you set them, and you told a unit when to engage on dehumidify, you have to enable it at this function. You can have everything set up and say just turn on the dehumidify and only enable it in the summer months and not run it in the winter months when it's less humid outside to try to retain some humidity. Then you have your irrigation and lighting. This is where, if you have crop lighting engaged, which this greenhouse does, you can engage them in various set points. You can set them to run a very common way. Let's go down all the way through here. It's a long way down sometimes. We'll get there. We're getting there. Yeah. So you can have them on at all levels of lighting. Set your delays for your lighting, your differentials. And this is the important part, is your scheduling. The irrigation lighting in this greenhouse is set to first turn on at 6 p.m. You can also set this to sunrise and sunset. So this will turn on after. Say I can set it to after sunset. 1 hour after sunset, this will turn on. Then I can turn it off after sunset, 3 hours. So that will allow it to run for 2 hours after sunset. This is what allows you to keep the same set points for your irrigation and crop lighting regardless of your sunrise and sunset changes, as long as you change them up in the set program. Or if you like, you can set the time either way. It'll function either way. But this allows you that if you go into your set program, in your set system, and change the sunrise and sunset, that it'll automatically operate at that level in your crop lighting and other features. So that's the ProCom in a nutshell. So we'll move to the WeatherMaster.